All right. So yes, so my name is Muffato, and I lead the informatics bachelor team in Sanger at Sanger, but also have the role of head of informatics for the whole department. So the department and our team are on a journey to seek. It's coming, yeah. So we are on 6 scientific programs of Sanger Institute, and we want to use DNA sequencing, genome sequencing, to answer a lot of questions about evolution and biology and the biodiversity and life. We've got a very large operations team within the department, more than 60 people that are building and running what's called the genome engine. So that's what we're using to generate all those reference genome assemblies. And I say for many species, we celebrated 1,000 genomes a few weeks ago. We actually want to be generating a few thousand genomes every year. And those are all novel species, and that's a difficulty because no one has ever tried sequencing and assembling the species, and there are a lot of issues. Just go along. So that's the overview of the genome engine. And before talking about Nextflow, there are people who are getting the samples in the field, sending them to Sanger, and then go to the core lab doing the DNA RNA extraction. Most of our pipelines start with concept of genome assembly and then analyzing the genomes. So we've got pipelines to make the reference genome assembly, and that's import data, pre-process the sequencing data, do an automated assembly. Then the curation team will run some decontamination step, and then there are a few pipelines to map all the evidence back to the candidate assembly, and then curate the assembly and have a reference gold standard assembly for that species at the end. But that's not the end. For every species, we aim to publish what's called a genome note. So it's a short publication that will state that, yes, we've collected and sequenced the species using that method. And that publication explicitly says that we are releasing all the data and they are free for public access without any embargo. And related to that, we run a bunch of standard genome analysis. That some of that we reported in the publication, some of that is we share with the community. So within our project, so within our department, within our projects, and with any user who wants to use data. Things like variant coding, for instance. So why are we using Nextflow? The decision was taken in spring 2021, right after I joined. So there was a large user base, the Sanger, but not just the Sanger, outside as well. So it's pretty well, it's one of the famous Nextflow workflow managers. It's got very good support for a range of HPC systems and cloud environments. And we know we've seen it being used on large-scale analysis. We also know from previous experience in various teams that sometimes doesn't work at scale. What it actually means and what's causing those issues, we actually we don't fully know yet. It's an ongoing discussion between Sanger IT and Secure Labs. And we'll be hoping that as we're ramping up our production, we'll be able to learn more and understand exactly why those things happen. But anyway, all the other workflow managers had their own issues, really. And then I should add that Sanger is paying Secure Lab for support. And then there's the Nextflow Tower interface that other workflow managers just don't have. But Nextflow is really just the core language. And there are many different ways of doing Nextflow. We decided to follow the NF core guidelines because there is an already existing set of standards for writing pipelines. So we didn't need to write our own, but it also means that we can piggyback a lot on their guidelines, processes, tooling, even training. So what NFCore states is that we start with containers. I mean, in theory, it also allows conda, but we only do containers, really. So each software is packaged as a container using Docker, and then can be executed on the farm using Docker or Singularity, or in the cloud as well. Each software is then wrapped into what's called a Nextflow module. And one module equates to one command, one function, that software. And then those modules are combined with sub-workflows, which can be combined in either more sub-workflows, but up to the overall workflow level. And all those levels, so starting with modules, but also sub-workflows can have their own tests. NFCore comes with a set of tools, command line tools, that will help you start new pipelines, write new modules, test modules, link your code. The repositories that are created on GitHub through that tooling naturally come with CI testing and all of that. And there's a very large user base. So both Nextflow and NFCore have got their own Slack workspaces with thousands of people on them. And are dedicated people in both Slack workspaces, but they're monitoring questions and helping all the users. Right, so we created our space on GitHub. All the code we're doing is open source, using the MIT license. All development goes through pull requests and code reviews, and actually something that people had to learn, because not everyone was familiar with that system. And I mentioned tests. So for each pipeline, we try to define test data sets. So a very small one that should run in the order of minutes, 10, 15 minutes at most. That can run systematically for every, so for people when they develop their own code, but also when you push to GitHub. And then a large one that may take hours to run, that's only run on when a major feature is added, or when we're about to make a release. And finally, to make everything public and scalable, we put in integration between our GitHub repositories and Synodo, so that when we make a new release, it makes a snapshot of the code in Synodo, it's got its own DOI, and you can refer to that version of the pipeline in publications, for instance. So that's mostly on the developer side, right? Next part is also about the users. So we created a website. We got our pipeline website. Actually, I can probably just quickly go through it. For those who are familiar with the NFCore website, they look the same because we forked their code base. But that's fine, so open source, right? And we asked them, of course. So it's linked to all our GitHub repositories. So we can see all our pipelines there. In particular, you can see which ones have been released. So this one's got version 1.0 that was released recently, 2 weeks ago. Some are still in pre-release. Some have had multiple versions, like this one's got 1.1, and some are still under development there. Because we follow the NFCore standard, every pipeline has got a usage. So not only there's introduction README at the root of the repository, there's a usage document here that explains how to run it, how to set all the different inputs and so forth. All the parameters, the name, description, the type, and so the outputs, what files to expect as outputs and how to interpret them. And with a sample of the output files here, maybe small browser here. And all of that comes from adhering to the NFCore guidelines. That's great. And so that website, that's what we're using that's what we're pointing all the users at, so they can see what we're doing and then understand better. Right. So as I said, we've got some pipelines that have got a version 1.0 release, some are still in development. Importantly, we've got some of them, well, half of them already running in production. And we've got another half that's just waiting for integration at this stage. All of that was done over the course of about a year and a half. So across my team and a few other teams, there's about 10 people who write Nextflow pipelines. And that was done alongside the daily production work and all the other R&D tasks about genome assemblies and method algorithms, all of that. Right, so how do we make this work? First, so in terms of infrastructure for our teams, we've got development environments deployed on the cluster. So that's the NF Core and Nextflow tools. We didn't mandate anything about the IDE, but most people ended up using VS Code. We've got good integration with GitHub. You can connect to a remote HPC through SSH. It's got all the linters embedded as well. If you come back to how we run our software, I said we're using containers. Although a lot of containers already exist, thanks to Backend containers, we still had to build some of our own. So we've got an internal GitHub repository with a pipeline to build new Docker images that are then made public on key.io. On the farm, we're using a system called SHPC to expose them as simple command line tools that people can play with as they are writing the commands and the pipelines. All our GitHub repositories are now managed through the pipeline website from NF Core. I've got a slide right to show that. So that website has got code to interact with GitHub using the GitHub API to list all our repositories, and then we've got a list of checks. So whether that's just a selection of those tests, those checks. So we're checking that we've got the GitHub wiki with GitHub issues, GitHub merge policy, rebase, squash, all of that set up for pipeline repositories and auxiliary repositories as well. With just one click. So when we want to create a new pipeline, we just create a new repository. Then we go to this website and it sets up all permission and access throughout. And finally, we've got a Tower agent deployed on our cluster, the Sanger, which means that when we want to run large tests, when there's a request, we can trigger that from GitHub. It will connect to the public Nextflow Tower, come back to the farm using the agent, and then run on the HPC. And then we have a notification on Slack when the run completes. There's of people, that was definitely the most challenging part. So Nextflow itself has got a very high learning curve. We didn't make it easier by adding NF Core and making Docker containers and dealing with development on GitHub, especially for people who were not familiar with any of those things before. So to learn about Nextflow and NF Core, fortunately, there's a lot of training available on the Nextflow and NF Core websites. And they hold regular events. They can attend through Zoom, but also all recordings are on YouTube. And they've got extensive documentation there. So that's why we're pointing our developers at. And recently, they added a new training called Advanced Training. That's really about doing Nextflow and improving at next level that people have found quite useful. And it's also on YouTube now. But I think what really helped is having hackathons. And there are different levels. So centrally, we organize one for the 2 o'clock level, doing one day every 1 or 2 months. And that was fine to create a sense of community. But I think what was even more efficient is when, for each pipeline, people made their own pipeline level hackathon. And they're just free to do that whenever they want. Of course, no, we're not managing when they're allowed or not allowed to have hackathons, right? So you've got then a group of, say, 3 people who can dedicate time. What was important is that at the same time as we organize hackathons, those were advertised to the other teams within Throughout Life. So they were told, please do not send any production requests or anything like that during that day, so that people can really focus on doing development during that day. And NFCore organized their own hackathon as well. So those are worldwide hackathons. But for a new starter, it's a good place to start with. NFCore is about writing modules to then combine them in pipelines. So a lot of the modules we need are added to the long list of NFCore requests, so that when people get time, so a lot of our modules end up being written by people outside of Throughout Life, because it's so shared there. And all the modules that we wrote ourselves, we deposited them to NFCore. But that was not all, because really we had to spend a lot of time in one-to-one with people. Can be in person during the hackathons or outside of the hackathons, can be over Zoom, over Slack, because there's a lot to learn and concepts that people are not familiar with. We just need to go really hand in hand with them and see things through. But like with any programming language, there are some good and bad or less good Nextflow developers, people who naturally adhere to the guidelines, people who just don't get it and do their own way, even if you ask again and again. But it's like in any software environment, really. But that's something you need to compose with, especially when trying to do things uniformly across a range of teams and for an integrated production system. Right, so then actually starting running those pipelines. The modules we get from NFCore, they're labeled with very broad resource requirements, which are called low, medium, and high. In practice, every tool will have a different balance of CPU usage, memory usage, and not just that, it also depends on the input, typically. So the default pipelines we have as they built from NFCore, they just really suboptimal. And we need to go and run the pipeline against multiple inputs, so find genome size and sort of things, gather usage statistics, and then just currently it's not automated. We need to go through the data and analyze, find correlations against the inputs, understand what drives the CPU and memory usage. Nextflow allows defining formulae for each process. So for instance, we found that this statics process, we found that its memory usage is correlated with the number of sequences in the input file. So we need to first extract the number of sequences. So there's some groovy code alongside that will count the number of sequences, and then we can have the formula 50 megabytes of RAM per 25 pattern sequences. Sample-sticked works differently. It loads entire sequences in memory, so its memory usage is going to be correlated to the length of the longest sequence in that file. So again, there was another piece of Groovy to extract that max length. But then once we've got it, we can write a, we can write it in the Nextflow file, say, okay, for every 50 million base pairs, that requires 50 megabytes of RAM. But that's just very tedious work. Now that we're starting running things at scale, we're going to feed all of the resource usage statistics into a database. And then we're hoping that machine learning will help us find or correlate with all the inputs. We'll see how that goes. But currently, at minimum, gathering all the statistics. Then another thing we found is that as a policy in NFCore, one module can only run one command of your software. So you've got the batch pipeline, where you've got the command A piped into another command, having another command. That's not allowed as an NF core module. I mean, it's still allowed as a local module in the pipeline. I mean, of course, Nextflow doesn't prevent you from doing that, but you won't be able to share it with other people, other collaborators through NF core. So again, that means that default NF core pipeline may not be optimal. I need to do a round of understanding how all different steps are linked and see where it makes sense, whether it can be joined. So in this case, there's a SAM tools view that's piped into BAM to bed. So it's convert a CRAM file to BAM, and then from BAM to bed, and we want to sort the bed file. With this single command, we only have one input there, and then the bed file at the end. If you're running that as different modules, the default NF core way, then there would have been an additional BAM file in the middle, additional bed file in the middle, and that's a lot of time spent on I/O, reading and writing and reading the file, and storage as well. I think currently we're still okay because we're not running enough pipeline to production, but it's something we've been very carefully monitor. I think, yeah, right. So our goal is to run process about 60 species every week through all those pipelines. So one species may remain in production for, say, 3 months, and we do first pipeline for the first few days, then maybe paused, then second pipeline 2 days later for another few days, and so forth. Currently, there are only 4 pipelines that are fully integrated running in production. Roughly, we're probably running about 20 or 30 a week on average. So we monitor this species really closely. I think that's the most difficult. The work directory that Nextflow creates isn't cleaned up until the end of the pipeline. So it just grows and grows and grows. And we've got some orchestration layer on top that checks the disk usage and only adds a new pipeline to the queue. It has enough space remaining. But then we need to make sure that when pipeline completes, we go and delete that work directory. We're also seeing a lot of leftover files on /tmp, and that's because when if a process exceeds its memory LSF, which we use on the HPC, we just kill it, and then all the files that open there will still remain. So we need to go and clean up /tmp regularly. We also found issues with some containers, some biocontainers that somehow don't mount /tmp properly, and they use /var/tmp. So I learned that there were 2 TMP on those machines, but to get to the space, we need to monitor and clean up. And finally, we know that the total number of files created and managed by Nextflow through the execution of the pipeline can create issues on the cluster at scale. And I still have only a discussion with Sanger IT about understanding when do things start failing, really. Is it simply the number of jobs? Is it about how quick the jobs are? That's still an investigation. So to conclude, we're writing everything to the Nextflow using the NF core principles. All our code is public on GitHub and on our pipeline website, and open source MIT license. And we're not finished yet. We still have probably maybe another year of finishing integrating other running pipelines. And with that, I'm happy to take the question.